All right, ladies and gentlemen, this is Geometry Chapter 15. We're going to do lessons 1 and 2 today. We're going to start with lesson 1. But this whole chapter is on geometric solids. Everything we have covered to date was either 1 or 2 dimensional. Very little did we deal with 3 dimensions, which is volume. Volume is 3 dimensions. So perimeter is like your 1 dimension. Area is your 2 dimensions. Now we are in 3 dimensions. So everything we've dealt with so far existed on a plane, but on 1 plane. But now we will have multiple planes intersecting in space to form a geometric solid. So all of these are planes that intersect somehow, and they exist in space such that there's this length, there's this width, and there's this depth. Okay? We have 3 dimensions now. All right, so but before we can understand all of 3 dimensions, we're going to talk about some basics. All right, so on page 618. We're going to talk about lines and planes and how they exist in space. Look at that picture on the top of page 618. What is interesting about that picture? Yes, Landry?
Top of the house-looking thing, this almost stair-looking thing, but it looks like it's going up, but at the same time going down.
Yes! People are going up and down.
That hurts my brain.
Yes. You're either going up or down. You can't just keep going up, 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 and the other side keep going. It's a visual illusion, right? It's a 3-dimensional illusion. They're walking in the opposite direction, but they're either always ascending in one direction, and they're always descending in another direction. All right, so let's look at the different concepts and postulates. So look at postulate 11. If I have 2 points anywhere, in order to call them points that are related, they must lie on a plane. And if those 2 points lie on a plane, then what can we do with those 2 points? We can connect them with a line, right? So if 2 points lie in a plane, then the line that we can draw with that must lie on a plane. All right, so a key concept here is lines lie on a plane. Lines do not exist in space. Lines lie on a plane. However, all right, so here's a line. Here's a plane. You agree this is a plane? Yeah. At the very edge of this could be a line. Do you agree? Yes. Yeah, that's true. I will not do a very good job of this, but these planes can intersect. And you know what intersects is the 2 lines that lie on the edge of the plane. So it's better seen this way. If I consider this to be 2 planes, right? I'm not going to tear it apart because then I won't be able to put it together. But if you imagine this were 2 planes, and this point is their point of intersection, then planes always intersect at a point where there's a line. And that's that next postulate. If two planes intersect, that point of where they intersect is always a line. It's always a line. All right. Now, that's planes, right? So planes can either intersect or not. Some planes never intersect. like the plane of that wall and the plane of this wall. They never intersect, right? Our planes can intersect. If they intersect, they always intersect at a line. This line lies on both of the planes. Got it? On the edge of both of the planes. All right? Now, in plane geometry, two-dimensional, right? Lines have options. Lines can either be like this, which that means they are parallel and they never, ever, ever intersect. Lines can be like this. And what do we know about that?
There's
Perpendicular, yeah. Closely related to this, lines can just intersect at any angle, right? They can intersect at a 90-degree angle. They can intersect anywhere. They can be parallel. There's one other option. So they're parallel, right? Or they intersect. Or, okay, y'all have to watch. If this is a line, are y'all watching? Here's the second line. What's true about those two lines?
Overlap each other?
They intersect at every point, right? They have all points in common. All right, either they have no points in common, they have one point in common, or they have all points in common. Those are the only three options for lines. And they always exist on a plane.
So, curved lines don't count as lines?
They're called curves.
Oh,
So, yeah, curves can intersect
in two places.
in two, or actually curves can intersect at 4 places. That's one curve. It's called a hyperbola. And they can intersect at 4 places, actually. All right, but we are only dealing with one dimension. Well, 1 degree, first degree values, all right? That is the option for lines that exist on a plane. There is another option for lines that exist in space.
Skew.
Skew. That is correct. Skew. Let's look at the definition for skew. Skew only happens when we're in 3 dimensions. Got it? Skew doesn't happen in 1 or 2 dimensions. Skew only happens in solids that exist in space. So let's go ahead and wrap our brain around that. All right? So look at this. 2 lines are skew if and only if they are not parallel and do not intersect.
Well,
Okay.
if they're not parallel, won't they intersect as a plane? Like if they're for
Okay, so I'm going to add to this definition. Skew lines only exist in 3D geometry and are non-coplanar. They don't lie on the same plane. That is correct.
And for 2 lines to be parallel, they both have to be on the same plane.
Okay, what is the requirement for lines to be parallel? They have to lie on the same plane. That is correct. We do not call non-coplanar lines parallel. We call coplanar lines parallel. Do you understand that? Coplanar lines can intersect and non-coplanar lines can intersect at a point. But skew lines are lines that are neither parallel nor do they intersect. Okay. All right, so look at your image that I gave you. This. Look at the top image. Okay, it's the big tent, maybe. I don't know, but that's the best description. It's actually a triangular solid. Okay? It's a triangular solid. All right. So, let's look at these lines, and we're going to decide which segments are skew. All right, so David, looking at AC. Okay, what must be true about skew? They are neither parallel nor do they intersect. Okay, so what lines are skew to AC?
BE.
BE. Any other ones?
EF.
EF.
DE.
DE.
I think
That's it. That's the three lines that are skew. Does that make sense?
Yeah. Wait.
BE, ED, EF.
It would be AD or CF because they're in the same lane.
Why would AD not work? Yes. It intersects at A. Got it? All right. What about EF? What lines are skew to EF? Go ahead, David. Not David. Chris. EF.
EA.
Is EA even a line?
He said DA.
DA. Yes. Yes. Thank you, David. DA is one. Yes. What else?
BA.
Yep. One more.
CA.
Yes. CA. Are you getting it? Okay, a little trickier. What about AD? What lines are skew to AD?
BE, B1.
Would what?
BE, or no,
Would BE, B1
No.
to AD?
was BC B1?
Would what?
BC.
BC is one
And then EF.
and EF.
Which ones do we say for EF?
AC, AD, AB. Or maybe AB, AC, AD. All right, so skew lines. They exist on different planes, right? And they are neither parallel nor intersecting. Got it? Make sense? So far. All right, let's look at the definition right below that. Two planes or a line in a plane. So, two planes and a line are a plane. This is parallel. Two planes and a line are a plane. Line and a plane. They're parallel if what? If they don't intersect. All right? Two planes and a line and a plane are parallel if they don't intersect. Parallel if and only if they don't intersect. I want to bring some distinctions here.
Where are you right now? Or are you
The very bottom of page 619.
so you're just talking. We're not doing the sheet.
Correct. Right. So we're going to talk about these in a minute. Two planes. So we can have two planes that are parallel if they don't intersect. And we can have a line and a plane parallel if they don't intersect. Okay, so let's look at our sheet. Back to the tent. All right. Do we have any planes that are parallel?
Yes.
Okay, which ones are they?
DEF and ABC.
Correct. Do you see that? A, B, C, and D, E, F. Those two planes are parallel. Okay. Do we have a line and a plane parallel?
Yes.
Okay, which one?
Line-
Okay, name the line and then name the plane. Go ahead.
The line is BE and the plane is ACDF.
Yes. So line BE is parallel to ACDF. Does that make it sense? Does that make sense?
Where are we on number 10? Or number 4?
No, we're actually on just
4. That's probably
just me asking questions. We were still looking at the first image. Can you name two planes that are parallel? Is that actually one of the questions down there?
Yeah, that's
Parallel
4.
planes. Okay, it's number 4. Yeah, I didn't mean to do that. But ABC is parallel to DEF. All right. And a line and a plane that's parallel. Okay, so what did we say? BE?
Line BE and
BE to
plane ACFD.
ACFD. That's exactly. Are there other examples of a line and a plane parallel? For number 5.
Yes.
Okay, what is it, Chris?
You could say,
Where? Oh, I see.
David?
AD and BCEF?
Yes.
BCFE.
You just go to every opposite side. Yeah.
Yeah.
Does that make sense? So far, we're good? All right, so turn the page. Now we're talking about perpendicular. All right, now we're talking about perpendicular. What means perpendicular? So this is different. This is different. Look, perpendicular is different for planes as it is for lines. Parallel is the same for planes and for lines and planes. But look, we have perpendicular. What does perpendicular mean?
Well, if it's two lines, it just means they intersect and form a 90-degree angle, or right angle.
But if it's two lines, it has to exist on a plane,
Right.
right? So notice we don't say two lines in either one of these, parallel, and we're not going to say two lines in either one of these because we're talking about 3 dimensions, right? Right? I already talked about lying on a plane. These exist in space, all right? So now, what is required if I have a line? I'm writing line, and a plane. What does your book say? How are a line and a plane perpendicular? Yes?
If they intersect.
Okay, one thing. They must intersect. Okay, what's the next thing? Yes, Selby Jane?
If the line is perpendicular to every line in the plane that passes through the point of intersection.
Here's the key word. Every line on the plane. Not just one. It has to be to every line on that plane that passes through that point of intersection. At the intersection. At the point of intersection. All right, that's key. We didn't have to have a line and a plane parallel at every point, just at that point of intersection for it to be parallel, or not, it just never had to intersect anywhere, right? Here, at every point of intersection, that has to form a right angle. Yes?
So it would have to be like, for example, a square with a cross in it.
Exactly. Yeah, yes, something like that. Yes. All right, now what if we have two planes? When are they perpendicular? Yes.
If one plane contains a line that is perpendicular to the other.
So how many perpendicular lines are required? One. Just one. Do you see? When we have a line and a plane, it has to be every line on that plane. When we have two planes, it only has one line perpendicular. Do you see the difference? One line on a plane is perpendicular to the other plane. Do you see the difference? This is the difference I wanted to really draw your attention to. If we have a line in a plane, it has to be every line perpendicular. Every line on that plane perpendicular to that one line intersecting it. Here, we only need one line on the plane to be perpendicular to the other plane. That's it. We only need one. All right, so remind me, what is skew? Skew lines. David.
Skew lines only happen in three-dimensional spaces, so they happen in space, and they're not parallel, but they don't intersect.
Correct. So they're non-coplanar, right? They're lines that don't lie on the same plane, and they are neither parallel nor do they intersect. All right? So now we have another word. It's called oblique. And we will use this in algebra. Oblique. What is oblique? Y'all look at that. Now regurgitate it, Landry. Go ahead. What does oblique mean?
It's a line and a plane that are neither parallel nor perpendicular.
Yeah. So they intersect, but not at a 90-degree angle. Oblique means not 90. Oblique literally, the root of that word literally means it's not 90 degrees. All right? So you can have oblique on two dimensions. Two lines can be oblique. That just means their intersection is not a 90-degree angle. All right? You can have a line and a plane that's oblique. Yes.
So they still intersect, just not in a 90 degree.
Correct. Yes. Yeah. You can have a line and a plane that are oblique, but they intersect, just not at a 90 degree. You can have two planes that are oblique. They intersect, just not at a 90 degree. Got it? So oblique means that they're not parallel. If they're not parallel, that means what? They have to intersect. If they're not parallel, they have to intersect. Does that make sense? Because parallel means never intersecting, so not parallel means they do intersect. Does that make sense? So oblique, they absolutely intersect, but their intersection is not perpendicular. It's something other than perpendicular. Got it? So oblique literally means intersection at any angle other than a 90-degree angle. Okay, so let's look at these last 8 through 13. Well, actually, let's do 6. We have another image. All right, some of you have answered no questions. All right, so some of you that haven't answered a question, we have a new image. Okay. All right, you see the figure? Its base is what? A, B, H, L, E. Do you see the base? Yeah? Everybody see it? For number 6. Name at least 2 lines that are skewed to E, J. What does skew mean? Skew means, what does skew mean? What does it mean, Ethan?
They're not parallel. They're not parallel. They don't intersect. Two different planes, three-dimensional objects.
Okay, All right, so can they exist on the same plane? No. All right, so which two lines would you say are skewed to EJ? GB, and what did you say? BH, DH. Okay? Would you agree? Look, I can't even keep the thing there. Would you agree? Why would you disagree? I would call those parallel.
Could you do G?
Would you call those parallel? Do they exist on the same plane?
I think so.
Does GB exist on the plane that EJ is on? No. Okay. So they don't exist on the same plane, right? So that works. Can we say lines are parallel if they don't exist on the same plane?
I think so. Because all that's required is that they never intersect, right?
No. What is the requirement for parallel lines?
They have to lie on the same plane. And
They have to lie on the same plane.
Oh.
Got it?
But it changes.
Two lines have to lie on the same plane in order for those two lines to be either perpendicular or parallel. They have to lie on the same plane. Got it? What have we dealt with here? We've only dealt with two planes or a line and a plane. Because if I'm dealing with two lines, then I'm assuming what? That they're on the same plane. Okay, so skew means they're neither parallel, which means they don't lie on the same plane, right? And they don't, what's the other part of skew lines? Intersect. So let's go back. EJ. He said DH, right? So what does it work?
Yes.
Yes. Does BG work?
Yes.
Okay, name another one.
GD.
GD.
CD.
Well, does AB work? Yes, AB works. CD works. So there's lots of them. Got it? All right, look at number 7. Name all the lines that are parallel to plane JFAE. Do y'all see plane JFAE? All right. Megan, what's a line parallel to the plane? What's required for parallel? Lines with planes. They just don't intersect. Lines with planes. Okay, they don't intersect. All right. So, what would be one of them? CL. Yes. Alexa, what would be another one? CD. Okay, I would say CD is not, because it looks like JEFE are like here. I would say that is not. I think if we, okay, here's what you have to imagine. We're only seeing a part of the plane. Planes go on in every direction. I think at some point CD would intersect JFAE. So what would be another one that would never, ever, ever intersect that plane? GB. Yes. And I only see one other one. Isabella? DH. Yeah, that's the only other one that I see. All right, now we have some true-false statements. I don't know. Okay, we're going to start with number 8. All right, Jack, are you ready? True or false? Number 8. Is plane A parallel to plane FGH.
Wait, is it a plane because it only has 3 points?
Well, it only gave 3 points to it, but it would be ABCDE,
Oh, okay.
and it would be,
Yes, it is true.
yes, it is true, yes. All right, Luke, what about plane ABH, which is ABHI, right? And plane, is it parallel to plane CDFG? No, because you have to remember planes are infinite,
Yeah.
right? They will eventually intersect. Does that make sense? Does that make sense?
Yes, ma'am.
Excellent. Okay. Abby, number 10. Is line AB and HG, are they skew? AB and HG. Okay, what's required for skew?
Well, I get,
They have to be non-coplanar, right?
alright, they're not coplanar.
They're not coplanar, that's correct.
Wait, what is skew? Wait, what?
Okay, requirements for skew lines, not parallel. Not parallel means they don't lie on the same plane, right? That has to go hand in hand.
So it would be,
Okay, so they definitely don't lie on the same plane. And do they not intersect?
well, they can't if they're not coplanar.
So that would be true, yes. Now, what line would not be skewed to AB? Which one? BC, that's right. BC. All right. Number 11. All right. Is AE, AE and BC. Oh, well, here we go. AE and BC, are they skewed?
No.
No, because they lie on the same plane. They are coplanar, right? And because planes are infinite, they would eventually intersect. All right. What about 12, David? CG and
I guess that's I.
AI, yeah, that's what I was trying to. CG and AI, are they skew?
I put false
Why?
because well,
So like,
they don't look like they're on the same plane, but they look parallel.
is there like an undrawn point that like technically could be there?
Could there be? Is
Right.
there a plane? Is there a plane that exists that may be ACGI?
That would just be determined on how, what the lengths are.
It would be like the square in the.
It is, and I would call that plane ACGI.
So no. So then. they
So
would
I would
not be-
absolutely say it's false, because even though we don't see a plane, just like these planes, we only see a limited piece of it, right? Planes go on and on and on. AI and CG could in fact exist on the same plane. That would be ACGI. All right, what about number 13, Ethan? CF. Okay, there we go, CF. And AJ.
Would it be true?
Anybody have any other thoughts? Okay, CF. What would you call CF to plane CDFG? It's called a diagonal, yes. How could we calculate the length of that? right, so I have C, D, G, F. C, D, G, F. So C, D, G, F. And that's CG. It's a diagonal. Is this the right
Oh, it'd be-
triangle?
Okay,
Pythagorean theorem. You see that? We could use Pythagorean theorem. This is tying it into the next lesson. Okay, all right.
what's the next lesson? Oh,
This.
the next lesson, not the next chapter.
Right, the next lesson. All right, so look at where AJ lies. AEJI. 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 Okay, are these two planes parallel
No,
in the image? Is
no.
AIJE, wait, I think I wrote that wrong. AEJI, yeah. All right, is this plane in the image parallel to this plane?
Yes.
Yes. Okay. This is a diagonal on this plane, and this is a diagonal. Could there be a plane that exists between them that's diagonal?
Yes.
So then, could
They're
they
not askew.
be skewed? They could not be skewed, right? Because these two lines can lie on the same plane and would never, ever, ever intersect.